For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below.
In this video, I'm going to show you how to find the determinant of a matrix using row reduction. So just focus on row reducing this matrix first, and then we'll talk about everything later. As always, I start with my first non-zero column. That's this one, and its top left position is my pivot. And then the idea is I want to kill everything below it to be 0. So these are 0, so we're good. Then I just have to kill this one. So I want to kill something in row 4 because this 2 is in row 4. That goes there. I want to use a pivot in row 1 to do so. Then I just add whatever's here. That's going to be row 4. And then to find out what I actually have to do, I'm just going to write these right here. So row 1 is 1, 2, 1, 4. Row 4 is 2, 0, negative 1, 0. And then I ask myself, what's the goal? The goal is to get this first one to be 0. So first one's going to be 0. And then I just focus on this one. How can I get that to be a 0? Well, then if this is a 2 and it's a minus, then this can be 0 when I add them. If I want to make this a negative 2, I'm going to have to multiply row 1 by negative 2 because whatever I do to 1, I have to do to all of them. So row 1 is going to be multiplied by negative 2. That means this is going to be a negative 2, this is going to be a negative 4, this is going to be a negative 2, and this is going to be a negative 8. Then I can just add as I said I was going to do. So this is already what I wanted, 0. This is negative 4, this is negative 3, and this is negative 8, and this is my row 4. So since I only changed row 4, that means every single thing is going to stay the same except row 4. I'm going to switch it with this one. Great, now we killed everything in this row, so we move on to the next pivot position, which is this one right here. But remember, if there is no number here, you want to switch it with the row where there is a number. So we're going to go and switch row 2 and 3. So I'm just going to take this, switch it with this one. This is the pivot position. Now we have a 2. So you don't need to get to reduced row echelon form. You just need to get to row echelon form in order to find the determinant of a matrix. This doesn't need to be a 1, so you could just leave it as that. And so again, you want to kill everything here, make everything a 0. So that means we're going to get rid of this negative 4 in row 4, and we want to use our pivot that is in row 2. So we're going to add, and then whatever's here, we're going to put that in there. And then to find out what we actually need to change in our equation, we're just going to drop these here. So row 2 is 0, 2, 1, negative 3. Row 4 is 0, negative 4, negative 3, negative 8. I treat it as an equation. I'm adding just like I am here. And then my question is, I want to make this a 0. I want to kill it. So that's the second one. So I'm going to go to the second one. This needs to be a 0. Then I focus on this. And I'm like, okay, how can I get this plus this to be a 0? Well, then this would have to be a 4 because 4 minus 4 is going to be 0. So I would have to multiply this by 2. So it's a 4. And whatever I do to one value, I have to do to all of them. So that's why I have to multiply the whole row by 2. So we're going to end up doing 2 times row 2. That's going to be 4, 2, and then negative 6. And then I'm just going to say that over here, and then I'm just going to add it as such. So 0 plus 0 is 0. This is already 0 like we wanted it to be. 3 minus 2 is 1, but negative 1. And then this is going to be negative 14. And this is my new row 4. As always, because I only changed row 4, all of these are going to stay the same, so I'm just going to go ahead and copy them. And the only thing that's going to change is row 4. It's going to become this. So 0, 0, negative 1, negative 14. Now we cleared out this row. Everything is good. Everything is 0. So then we move on to the next pivot position, which is this. So I want to kill anything below that. So this needs to go away. So I want to kill something in row 4. I want to use my position that is in row 3 to do so. Then I'm going to add whatever's here. That is row 4. And then to find out what I need to change in order to kill this, I'm just going to rewrite the rows here. So row 3, row 4. Row 3 is 0, 0, 3, 0. Row 4 is 0, 0, negative 1, negative 14. Then I ask myself, what's my goal? My goal is for this third number to be 0. So 1, 2, 0. Then I just focus on this. How can I change row 3? I'm always changing the blue. Row 3, so that when I add it to negative 1, it gives me 0. Well, I can just make this a 1. So 1 minus 1 is going to be 0. So to get this to be a 1, I would have to divide by 3. So I would have to divide the whole row by 3, which in other words is the same thing as multiplying by 1/3, because remember, technically we don't divide in matrices. So it's going to be 1/3. That's going to become a 1. And then I just add like I said I was. So this is going to be 0, 0. This is already 0 because we made it that way. And this is going to be negative 14. And that's going to be our row 4. So then our matrix is going to be the exact same thing, with the only difference is, since we changed our row 4, now it's going to look like this. And now we see that our matrix is in row echelon form. So remember to check ZO plus 1C. This is for row echelon form. This is for reduced row echelon form. All 0 rows have to be at the bottom. There are no 0 rows, so we don't have to worry about that. The matrix has to satisfy the staircase rule. That means you circle all of your leading entries, right? It's the first non-zero entry you see in every row. And then you want to start with the first one, keep going, and then down until you see the next one, down when you see the next one, down when you see the next one. If the staircase is one step each, then it satisfies the staircase condition. Because remember, we like one step staircases, not staircases where the step looks like this, because if you take that step, honey, you're gonna die. So we don't like that. We always just like one. So if we did that, that wouldn't work because that's 1, 2. We don't like steep staircases. And then this stands for 0. All of the entries below the leading entries are 0, and they are. So therefore, these are all checked as in row echelon form. And to find the determinant, we don't care about reduced row echelon form, just row echelon form. And so the idea is that the determinant of the matrix A, if this is your matrix A, is going to be equal to just multiplying the diagonal rows starting from the first entry. So that's going to be 1 times 2 times 3 times negative 14. This is going to be negative 28 times 3. That's going to be negative 84. But this is not your determinant just yet. You have to undo the operations that you did, and that is where these rules come in. So the first one is if you do a row switch, you have to multiply your final determinant by a negative. So how many row switches did I do? I only did 1, so that means that I have to multiply my final answer by a negative. So that means this just becomes positive. Now the second one is if you scale the entire matrix by a scalar called c, in other words, whatever real number, then you have to divide your determinant by that c. So don't get confused. This doesn't mean, oh, we scale a row by -2 or by 2 or by 1/3. No, this means we're multiplying the whole thing by 3, and we never did that. So therefore, there's nothing to do here. And then the final one is if you do row addition, that also doesn't change your determinant. So keep track of them. If you have 1 row switch, then you're only going to multiply by 1 negative. In other words, when you have an odd number of row switches, you're going to multiply by negative. If you have even number of row switches, like let's say you only did 4 row switches, then you do nothing because it's negative times a negative times a negative times a negative, positive times positive, right? It's just going to end up being positive. So this here is the determinant of our matrix 84. So it's just multiplying the diagonal, and then you just follow the rules. If you row switch, multiply by a negative by however many times you row switch. If you scaled the matrix, the whole matrix, by some scalar, then you would just divide this by whatever you scaled it by, c. And then row addition clearly does not make a change, so you're good there. So that's how you use row reduction to find the determinant of a matrix. I'll see you in the next video.